Hi, in today's lesson, we are going to be learning a new method of, or starting to learn a new method of solving where we use what's called the quadratic formula. But today's focus will be strictly on the discriminant, which is a part of the quadratic formula. So if you look at today's announcement in Canvas, it says, thank you so much for all of those of you that are keeping up daily. So many of you have A's and B's. And that is because you are doing a great job of watching the videos and learning, or either joining Zoom during the scheduled time. So Miss Allen has Zoom from 10 at 10:25 Tuesday through Friday for Miss Robinson. I'm Miss Robinson speaking. Mine is at 1:40 p.m. during fourth period, and Miss Klein Pierce is during first period and from 3 to 4 Zoom hours. 3 to 4 are Zoom office hours. So today, guys, yes, it is important to make sure that these assignments are completed from last Thursday, Friday, and Monday. Yesterday, which is Monday's practice, came from practicing skills learned Thursday and Friday. So thank you to those of you that got that done. Understand that your next test on solving quadratic equations will be, it's actually a week from next Monday. Most of us are testing on, let me give you the date. Most of us are testing on the 2nd, November 2nd, I believe. So that will be really important to keep up, as that is the last day of the marking period. So that will be the last day to have all assignments completed. Or actually, I apologize. The test is not November 2nd. It is the 26th. We're actually going to finish up this week. Test review Thursday, and then test on Monday on your virtual day. So today you're going to go to Delta Math and take notes on this video that I'm creating right now. There is a handout for today's notes and practice problems to print below. So I wanted to highlight this, that if you come down here, you'll be able to see the document that I use in the video. All work for Delta Math does need to be either in your notebook or on the printouts if you're able to print, because I did, part of the printout is the actual problems typed up. And then you're going to join class via Zoom if you'd like to go through it live together, so I encourage you to do so. So you would click on this form, and then it's going to open up this document. This is not something I expect you to take notes on, okay? This actually is a concise compilation of the methods that we have thus learned, solving by factoring, and then solving using the square root property, and then the last method we're going to teach, which is solving using the quadratic formula. I give you hints about which method is best. So let me just quickly recap. Solving by factoring is awesome if you can factor, but you can't always factor. So if our solutions are rational, so remember that solutions are another word for zeros or x-intercepts or roots. In other words, where the parabola hits the x-axis. If they are at normal pretty numbers like fractions or positive or negative whole numbers, then this is going to be the easiest method, factoring. And then I have 2 examples worked out, and then verbal steps right here in words for you. So this is going to be a great reference sheet for you to print out if you're capable of, or at least save in your files to refer back to. For square root property, it's going to be great when we have a quantity squared in the problem, such as like these right here in this example, if you can see my mouse moving. We did those in Delta Math on Friday, as well as if your linear term, your bx term is missing. So you can see right here, for this first example, we have a quadratic term and we have a constant, but we don't have the x to the first term. So that's when square root property is great. So I worked a couple of examples there and again gave you the steps. And then lastly, the quadratic formula, while if we take a look at this, it is the only method that works 100% of the time, it is not always the easiest, because simplifying, you've got to be great at simplifying math, okay? So understand that if we get rational solutions, we can solve by factoring. If we get this square root property, technically you could get either rational, irrational, or imaginary solutions, but we can't always use this method. So if it was in the form of, like this right here or this one right here, then square root property does not work. So that's why I wanted to have examples under the method, okay? But again, quadratic formula, it does help you to find rational, irrational, or imaginary solutions. It's not always the easiest and it requires great attention to detail, but it is the only method that works 100% of the time. So can we use it instead of factoring? Yes. Can we use it instead of square root property? Yes. Is it always the easiest? No. But notice for these two methods, the solving by factoring and quadratic formula, you must first set your equation equal to 0, which is what the practice on Monday was about, with practicing using these two methods, solving by factoring and square root property, but there were a few that you had to set equal to 0 first. So we are not going to go into all the steps today for using quadratic formula. That is tomorrow's lesson. But I do have a problem worked with all the steps. You can see these steps down here, but here I'm applying the steps, and I have a picture of a problem worked plus the answer. So this would be a great reference sheet, but like I said, we'll spend more time specifically on using quadratic formula tomorrow. So next, in order to understand quadratic formula, which is this formula right here, we actually have a song that we'll use for that tomorrow. What we're going to be doing is concentrating first on the b squared minus 4ac part. This part here is known as the discriminant. If we think about the word discriminate sometimes has a negative, or a lot of times has a negative connotation, but in mathematics, to discriminate means to tell the difference between. So if we want to tell the difference between the types of solutions we get, it is important to understand what the discriminant tells us. So to find the discriminant, and I use D for discriminant, we're going to simply evaluate b squared minus 4ac. Well, where the heck does b squared minus 4ac even come from? It is part of the quadratic formula here, this b squared minus 4ac, but specifically the a, b, and c values come from the quadratic equation when it is in standard form, ax squared plus bx plus c. Well, the discriminant is going to tell us one of two things. It's going to tell us, are our solutions real, meaning our parabola touches the x-axis, or are our solutions imaginary, meaning our graph will not cross the x-axis, won't touch it or cross it. So how do I know? It really has to do with the value of our discriminant, okay? So again, there's possible to get real and imaginary solutions. Well, let's talk first about the real solutions. Just like when we did understanding the complex number system at the very beginning of the course, we talked about that real numbers are numbers that are either rational or irrational. Try to think back. If you need to just hit the space bar and say, yeah, let me go look back through my notebook and remind myself of this. Rational numbers are numbers that can be written as a ratio of two integers, meaning they could be fractions or they could be integers, like positive and negative whole numbers. So how do I know if I'm going to get a rational number? I will know if my number is rational if my discriminant comes out to be 0. So in that case, if my discriminant, if when I plug in b squared minus 4ac, if it equals 0, I know that there will be real, rational, equal roots. And in fact, there will be 2 double roots. So sometimes in Math 3, teachers will say, hey guys, we've got a double root here. And what that means specifically is it bounces off the x-axis. But I'll show you a sketch in a minute. If our discriminant is a positive number that happens to be a perfect square, then we will be able to simplify that square root in our formula. Come up here. We're going to end up tomorrow simplifying these square roots. So if it's a perfect square, then there will be no radical, and we will have 2 real, rational, unequal roots. So that's if our discriminant is either 0 or, in this case, a positive perfect square. I should have put a plus in front of that. A positive perfect square. We also can get real solutions that are irrational if we get a discriminant that is a positive non-perfect square. So remember, NPS, back to the beginning of the semester, means non-perfect square. So remember, a perfect square is a number like 36, because the square root of 36 is 6. The square root of 1 is 1. The square root of 4 is 2. Over here, if we get a value like 5, then we cannot take the square root of that value, okay? So that means, or excuse me, we can simplify it, but we can't get an integer when we simplify this square root up here. So again, remember, today is nothing but starting to learn what the heck does this discriminant tell us. Then, of course, if it's not real, it could be imaginary, meaning our graph does not touch the x-axis. Well, when will that happen? That will happen if our discriminant is less than 0. So that's what that means, d less than 0. Well, any number less than 0 we know is negative. And in the case that our discriminant comes out to be a negative number, there will be 2 imaginary roots. So now I'm going to just quickly talk about what the sketch of a graph might look like, and I'm going to switch over to my paper copy so that we can draw these in. So if I were you, I would keep this sheet as a reference, but add in this table in my notes if you do not have the capability to print. Okay, so if you want to pause the video at this time and then copy the table, you can. But I'm going to go ahead and switch over to my ladybug, my document camera here. And I just want to add a couple of things in talking with the Math 3 teachers, and I've taught Math 3 a whole bunch. Keep in mind that if we have rational equal roots, it can also be referred to as a double root. So I want you to just add that if you can, double root. Okay? All right. So let's talk next about what does this discriminate indicate that the roots of the graph will look like. So if I have real unequal, that means not the same. So 2 equal roots, real equal roots, again, that's when our discriminant is equal to 0. So discriminant equals 0. I'm going to add this to my top of my table. Real unequal. Notice here I have unequal, and they're both real, are they not? Real, unequal, real, unequal. That means I could have rational or irrational solutions. So that's what I'm going to illustrate here in this box. And then over here for imaginary, what will that end up looking like, okay? So if I have real unequal roots, but I have rational solutions, rational numbers can be both fractions or integers. So I'm going to make that 1 and that 2. So halfway between 1 and 2 would be 1.5, or the fraction 3/2. So if I have 2 unequal rational roots, I potentially could have a graph that, and I'm not drawing specific, of course, I'm just showing you the behavior of what it might look like when it hits the x-axis. Rational solutions means I could have an integer or a fraction. Irrational solutions might be, let's say this is -1 and -2, and +1 and +2, and when I find my discriminant, I get a discriminant value of 2. Well, what we will find out using the quadratic formula is that when we simplify this, we're going to get an irrational value. So let's say that our solutions end up being, when we solve using quadratic formula, we get x equals positive or negative square root of 2. Well, we can't find specifically square root of 2, but we can estimate its value. So if I type in the square root of 2, I get approximately 1.41. So I'm going to put approximately plus or minus 1.41. Well, that means I'm somewhere between -1 and 2, almost 2.5, but I'm closer to 1 than I am to 2. And then -1.41 would mean I'm somewhere between -1 and -2, but closer to -1 to the -1 than I am the -2. So that would be our -1.41 approximately, and this would be our positive 1.41. So that's what I mean by 2 irrational roots. And of course our parabola could open up or down. So I'm just showing you again the behavior of what the discriminant tells us about where the graph, or the types of solutions where the graph hits the x-axis. So what if I have real equal roots? Well, real equal I could have real equal roots that are integers, or I could have roots that are irrational. It is possible. So I could have, let's say again, that my root is x equals the square root of 2. But I actually get 2 of them. That means that, again, that value of approximately 1.41, so closer to 1, but in between 1 and 2, I could have it bounce off the x-axis at that value. That is possible, okay? It could be at an irrational value, or it could be at a rational value. So I'm going to do 1, 2, 3, and have it bounce off at 3. So here my x would equal 3, but technically it means I have 2 solutions. I have 3 twice. And the reason why is because if this was factorable, it would be x minus 3 and x minus 3. Just a FYI, which is x minus 3 quantity squared. So anyway, if I were solving that, then I would get 2 solutions of 3, right? So real and equal. And then I could have imaginary. So we know that on an x-axis and a y-axis that you are either going to see them hit the x-axis or you're not at all. So if we were to graph, say, the function x squared plus 2, when I graph it, that doesn't hit the x-axis at all. So that tells me that my solutions are not real, because if they were real, they would hit the x-axis. So that's what I mean by up here. If they do not touch the x-axis, they're not real, they're imaginary. So that means I could have a parabola floating up here in the air. It could open down. Maybe it's in quadrants 3 or 4, but the point is it will never hit the x-axis. So again, real unequal, it could hit 2 different places, but at different values. I could have real equal, where I have an irrational and a rational, and there it bounces off the x-axis. Or I could have imaginary, which means it does not cross at all. And again, all of that is going to be based on the value of d. So again, here, if my d is positive, I've got this option. If my d value is 0, I have this option. And if my d, my discriminant, is, if my discriminant is negative, I'm always going to have imaginary solutions. So again, to summarize, this chart will help you understand that you can have either, real or imaginary solutions, meaning they either touch or do not touch. You could have solutions that are rational or irrational. And you can have imaginary solutions, meaning it does not hit the x-axis at all. But that if your discriminant comes out to be 0, you're only going to get technically 1 number, which counts as technically 2 solutions. It's just the same number repeated. So that's why we call it double roots, or rational, real, rational, equal. They're going to be equal to each other. In this case, 1.41 and 1.41. And in this case, 3 and 3. All right, so now we're going to move on to the Delta Math assignment. So let's go. So if you do not have the capability to print, each of these needs to go in your notebook. You can fill it in as we go on Delta Math, but I certainly would encourage you to write a table and have all of your answers in table format. So again, as a reference, I have the quadratic formula up here, but when we talk about the discriminant, we are only talking about this right here, the b squared minus 4ac. So for this, it says find the discriminant of each equation, use it to determine the number and types of roots, and remember your nature of your roots. Your possibilities are, from your sheet, you can either have 2 real rational equal roots. You can have 2 real rational unequal roots. You can have 2 real irrational unequal roots. trying to think, can we get... Yeah, it's possible, but you are rarely going to see the double irrational, but it is possible. So I'm just going to list these because that's all we're going to work with today. Or you can have two imaginary roots. So when we say, tell me the nature of roots, the number and type, this is what we want you to write in the box. That there are either two real rational equal roots. And again, when does that occur? That occurs when d equals 0. You can have two real rational unequal roots. And that is when your discriminant comes out to be a value that is a perfect square. You can have two real irrational unequal roots, and that's going to happen when your discriminant comes out to be a non-perfect square. So I'll just, for example, like 36, 49, 1, 121, etc. Non-perfect square like 5, 13. Those are not perfect squares, right? 23. And imaginary, again, is going to be when your discriminant is less than 0, meaning negative, okay? So that's really all you're focusing on today. I know I've talked about a lot, but this is the crux of today's lesson. Once we get this down really well today, then we'll be ready to apply the quadratic formula. So I'm just going to go through a few of these, explain how you would type them in, or how you would find the answer, then we'll go back in Delta Math and put our answers in, okay? So let's talk about number 1 first. So one thing that will be important is that in order to use quadratic formula and then find the discriminant, it has to be set equal to 0 first. So after, and if you'd like from the first sheet, by the way, the first steps right here, A, B, 1, 2, and 3 are all about finding the discriminant, and then you're going to tell what it is. We're just not doing steps 4 and 5 today, okay? So again, we want to set it equal to 0, and notice these are, but when you get over to, if you printed problems 6 through 8, so just 3 of them, you have to set to equal to 0 first. And then we are going to identify A, B, and C coming straight from our equation. And then we're going to plug into this b squared minus 4ac. So step 1, identify, make sure it's set equal to 0. And then step 2, what's your a, b, and c? So my a value is my quadratic coefficient, also known as the leading coefficient. So that's 1. My b value, and you have to pay close attention, is a negative 8. And my c value is negative 9. Remember that signs belong to the number that follow. And now we're simply going to plug this in and then use our calculator to evaluate. The one way that students get this wrong the most is they don't use parentheses. My recommendation is always going to be to use parentheses around B and A and C when you type it in the calculator. And the specific reason is we do not want to, when we square a number, include the square on the inside. How you type it in your calculator definitely matters. So our discriminant is going to be the square of B. Now you may look at B and go, oh, if I'm going to square it, then negative 8 squared means negative 8 times negative 8, which is 64. And you can totally do that. So negative 8 squared, so if you want, write 64 instead. If you're good at mental math, you may prefer to do that, and then you have less calculator errors. Your A value is 1, and your C value is negative 9. So at this time, this is when you would get out your calculator, be it your Calculator 84 app, or if you have a graphing calculator. So I'm going to go in here and type in negative 8 squared, exactly the way I wrote it down, minus 4 times 1 in parentheses times negative 9 in parentheses. I like to just be consistent with parentheses so you don't have to think about when do I use them and when do I not. Let me focus that a little bit. So I plug that in. Negative 8 squared minus 4 times 1 times negative 9. Hit enter and I get 100. Sweet. Well, what do we know about 100? 100 is a, sorry, $100 is a perfect square. So if 100 is a perfect square, then I am going to look right back here and I'm going to write that I have, because it says number and type. So I have two, but what type are they? Real, rational, unequal roots. Two real, rational, unequal roots. So what does that mean? It means when I graph it, I'm going to hit, so if you need to refer back to the chart where I drew the graphs. So if I have two real unequal, because it's a perfect square, did I write rational? Yeah, I wrote rational. Two unequal rational, then I'm going to get a positive and sometimes positive negative, sometimes a negative negative, sometimes one of each sign. But I'm going to hit the x-axis twice. That's what that means. I'm going to hit the x-axis twice. So I just want you to draw a quick sketch of a parabola that hits the x-axis 2 times. We do not have to specify any specific value. All right. I'm going to move on and do number 8 now, or excuse me, number 4. 1 and 3, of course, are in the same format, so you should be able to handle those. So again, step 1, make sure it's set equal to 0. Step 2, state your A value, your B value, careful, that's a -5, and a C value, and that's a +3. And we're going to substitute it into our discriminant formula. B squared minus 4 times A times C. That's all you're doing today, guys. You're substituting into this formula. You're going to simplify it. I'm going to use a graphing calculator this time in case you have a graphing one at home. But certainly we can use our Calculate 84 or our Wabbit Emu app. So -5. Oops, I forgot my square. And we get -71 this time. So I substituted it, hit enter, have value of -71. So you can see that even if you're doing this on paper, this is what I need to see. You need to have the table headers so that later on, when you look back through your notebook, you know what you're looking at. You need to have the equation. You need to identify A, B, and C. If I'm writing it down, you should be writing it down. You're going to show me what you're plugging in the calculator, what you get when you type it in the calculator. Then you're going to look back up here and go, okay, if I have a negative number, what does that mean? Oh, it means I'm going to have 2 imaginary. So I'm going to come over here and write 2 imaginary. Now, in terms of a sketch, what does that mean? Well, for one, I know my parabola has a positive A, so it's going to open up. But all I know is it's just not going to hit the x-axis. So I'm just going to draw a sketch of a parabola that opens up, that does not hit the x-axis. And that's all I need you to do. Next, for number 5, I want to do 5 with you because notice here we have a -5. But when I look at number 5, I notice that 5, 30, and 150 are all multiples of 5, which means I can actually do a cool trick to make solving easier. So I wanted to go ahead and give you a heads up that we can do this tomorrow as well, and it will make solving so much easier. If all 3 numbers are divisible by a common factor, in this case I'm going to use a value of -5, we want to reduce by dividing every factor by that number. Why? Because now that's going to cancel out. And that's going to give me x squared. Negative divided by a negative is positive 6x. And then a -150 divided by -5 is a positive 30. Make sure. Yep, 30 equals 0. So next step is set equal to 0, and it simplifies and make my life so much easier, because if we can simplify at the start instead of simplifying at the very end tomorrow, that's going to make life way easier. So my A value is now an understood 1. My B value is 6. My C value is 30. Discriminant is B squared minus 4AC. And then we're going to type it in. And I usually just square the number in my head. But if you want to go ahead and just type it in square, that's fine. Minus 4 times 1 times 30. I guess I'm not modeling for you exactly what I said, right? 6 in parentheses minus 4 times 1 times 30. And we get a negative 84. All right, well, that happened again. We got a negative value, so that tells us if it's negative, right back up here, we're going to have 2 imaginary. And in terms of solving solutions, it means I can find the x values, which will be the same no matter if it opens up or down. But originally, our polynomial did have a negative a value, so it's going to open down. Sorry, let me send her a message real quick. All right, and that takes care of that for number 5. All right, so just a quick reference over here for Delta Math. When I go to the Delta Math assignment and I'm doing number 1, what is the discriminant of that equation? For number 1, we got positive 100, so we would choose 100 and submit. And that's it. But here they, again, do the exact same thing, don't they? They list A, B, and C. They show you that they're substituting, so I like that this is color-coded if that's helpful. And then you're simply stating the value. But again, this is prerequisite to understanding quadratic formula. No. All right. And then next. So I want to do, at 6 and 7, I simply want to set up for you, and then you'll do the rest. For number 6, notice that these are not set equal to 0, and that's our first job. So notice I already have my ax squared and my bx and a constant, but I have another constant, and it has to be set equal to 0. So if I want 0 over here, I would have to add 6. But if I add 6 to one side, I must add 6 to the other. And negative 9 plus 6 is negative 3. And now I can list my A, my B, and my C. And I'm going to let you finish the rest, okay? Number 7, notice I have ax squared plus bx equals c equals ax squared plus bx plus c. Again, so I want to move everything to the left so I can make sure it's ax squared plus bx plus c equals 0. So watch what I'm going to do. If I subtract 6x squared on the right, I'm going to subtract it from the quadratic term on the left. If I subtract the linear term on the right, I'm going to subtract the linear term on the left. And if I subtract the constant term on the right, I'm going to subtract the constant term on the left. So what I do to one side, I do to the other. So now that canceled out and it's equal to 0. 7x squared minus 6x squared is 1x squared. 23x minus 3x is 20x. And 168 minus 7 is positive 161. So now I've done step 1, which is make sure it's set equal to 0. So my A value is 1. My B value is 20. My C value is 161. And I'll just go ahead and finish this up with you. So discriminant is b squared minus 4ac. If you want, come up here at the top of this page if you print it out and write that up there again. Since that's like a formula you have to memorize, and you do have to memorize that. Now we can type it in. So now I've typed it in with parentheses. You can see I kind of got a bad spot on my calculator. And I have negative 244. We keep getting these imaginary ones, don't we? So again, look back at the first part, the nature of roots, and if it's negative, we're going to have to imaginary, and it's not going to hit my x-axis at all. So that's all I expect you to do, guys. Just as a quick recap, for 8, I can add 6 to both sides. Some of you, I would just want to talk about this real quick because you might go, can I do blah, blah, blah? And I want to show you that you can. So if I have negative 32 equals 0, so notice all these are negative. So you might be asking, can I maybe divide by the common factor of negative 1? Yes. In fact, I definitely would recommend that because when you go to solve, it makes it a whole lot easier to solve when you have positive values than it does when you have negative values. So here I have x squared equals, x squared plus 18x plus 32 equals 0. And that's going to be a lot easier, right? So since I don't have much room here, I'm going to come over here to my a equals 1, b equals 18, and c equals 32. And I'll let y'all finish that. So notice, because I can divide out the negative for number 8, I can also do that for number 9. So I'd want you to do that. And you're just going to keep going, guys. You're just going to go through and find the discriminant, tell me what types of roots, and then do your graph, okay? We can also do that, divide by a negative here on 14. If you're like, Miss Robinson is going way too fast, just remember, guys, all these problems are the same ones in Delta Math, so you can, if you want, write them down as you go through Delta Math if you were unable to print. Notice here, I divided by a negative before setting it equal to 0, but that's okay. I can do it after. And then I would continue finding my A, B, and C. Discriminant, what kind of root is it? Graph it. So just wrapping up, guys, that's what you're going to do for each of these. For 7, because we already did 7 in the video. Notice for 1 through 4, they're multiple choice. For 5 through 8, so there's 4 of them, you're actually going to type in the value of the discriminant. So for number 7, we got negative 244, and that's what you need to type in. But notice, guys, I am asking you to fill this table out for all problems. The table that I'm going over in the notes. Notice for numbers 9 through 14, after you find the discriminant, you then have to tell me what kind of roots you do have. Interesting. So that means you will need to fill out the table and then just come back and choose your nature of root. And that's it. They're not hard. And then you actually have something timed here. So I just want to talk about these real quick. So we have this set that you need to get a certain number correct, and then it'll tell you congratulations. But what will happen is if you have to find the nature of the root, if they tell you, oh, my discriminant is 81, I want you to go back. You can either go back to, let me show you. You can either go back to here, or you can go back to the top of your notes or this sheet to answer these types of questions. So have your notes handy to help you. So if notice 81 is a perfect square. So if I have a perfect square, it's going to be 2 real, rational, unequal roots. 2 real, rational, unequal roots. Okay? 14 is not a perfect square. So, but it's positive, so that would be 2 real, irrational, unequal. If my discriminant is 0, that is 2 real, rational, equal. Real, rational, equal. And that's how it works. Real, rational, equal. So it's just kind of like a skill drill to help it get in your head really good. 49 is a perfect square, so that's 2 real, rational, unequal. So you need to learn how to do this, but keep in mind that you will have your notes to be able to take your test. So if you're like, oh gosh, this is too much to remember, you'll be able to use your notes as a reference, okay? Now here, you are asked to find the value, like what's a possible value. So if it touches 2 times, remember that if our discriminant is 0, then it will sit on the x-axis. If it is negative, it will be imaginary and not touch the x-axis. So if I see it touch twice, it's a positive value. If it sits on the x-axis, that means my discriminant was 0. If it does not touch the x-axis, my discriminant is negative. Touches x-axis, so 0. Touches 2 times, so it's positive, etc. So that's what you'll do. You just go through and practice a few of those. And then lastly, do a few where you're going, okay, what does this mean? So if it touches 1 time, it means I have equal roots. If it does not touch at all, I have imaginary roots. If it touches twice, they are real but unequal, which means I have 2 different roots. Doesn't touch, imaginary. Touches once, equal. Touches once, equal. Does not touch, imaginary, etc. All right? So good luck and join us for class if you like, but refer to this video often, or at least maybe watch it once or twice to help it all sink in. And if you're able to print the reference sheets, great. If not, make sure you save those reference sheets somewhere handy so that as you're doing your work and preparing for your test, which will be like next Monday, then you'll be ready to go and you'll have these handy. So do not lose your notes nor your practice stuff. You will take a picture of the last 2 pages of the document, or at least the table where you are working this out. You do not have to take a picture of like all the notes because I don't expect you to write out pages 1 and 2, with the exception of the graphs at the bottom where I did like sketches, okay? Let me show you what I mean. Like where I did these sketches. This needs to be in your notebooks for sure. And then send a picture of the tables of working out these problems. These problems will be due the day after tomorrow. So if you feel like, well, it's a lot of work for today, you can finish it up tomorrow, but we are going to have a new lesson on using the quadratic formula. And then Thursday and Friday will be focused on practicing those methods. All right? So good luck and let us know what you need help with.